Dear students, hope you are great. Today we are going to take chapter 2, one-dimensional motion, section 3, falling objects. Free falling bodies undergo constant acceleration. When bodies or objects fall freely, it undergo constant acceleration. For example, look at this image. Feather and an apple are released from this chamber. Is a vacuum chamber, so it released from vacuum chamber. The two objects, look here, pull exactly at the same rate as indicated by horizontal alignments of the multiple choice images. The amount of time that passed between the first image and second image is the same as the amount of time between fifth and sixth. The picture, however, shows that displacement in each time interval, so the displacement in each time interval did not remain constant, so it changed. Therefore, the velocity was not constant, meaning change. Why velocity was changed? Because velocity means displacement divided by time. So when displacement change, velocity will change. So the velocity change as it increase. Why velocity change? Because the displacement. Look at displacement change. Compare the displacement between the first and second image to the displacement between second and third image. As you can see, within each time interval, the displacement of feather increase, displacement increase. So the velocity increase. Displacement increase by the same amount as the displacement of an apple. So displacement of the feather increase as the same amount an apple increase. We know that velocity, why? Because the time interval are the same. Time are the same. Distance time are the same. So when the displacement increase, the velocity increase. We know that the velocity of each object is increased by the same amount in each time interval. So velocity increase and the displacement change or increase. In other words, the apple and the feather are falling with the same constant acceleration. So the apple and feather are falling with the same constant acceleration. It's the same constant acceleration. If air resistance is disregarded, all objects dropped near the surface of the planet fall with the same constant acceleration. So when the resistance is disregarded, like a vacuum chamber here. So what happened? All objects are pulled at the same constant with the same constant acceleration. This acceleration is due to gravitational force. So why apple and feather fall at the same constant acceleration? Due to gravitational force. And motion is referred to as free fall. So an apple and feather both are not have the same mass or the same weight, but in a vacuum chamber, or when the air resistance is disregarded, what happened? Both fall at the same constant or at the same constant acceleration. Why it fall at the same constant acceleration? Because due to gravitational force. Watch this video.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out 30 tons of air. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest.
Here is a...
Now in this case, the
air
feathers
resistance.
fell to the ground at a slower rate than the bowling ball
So what
because of air
happened?
resistance.
Fall first, then the feather.
So in order to see the true nature of gravity, we have to
This
remove
is
the
due to air
air.
resistance.
We dropped
But
2
if air
millitorn in the last
resistance is
30
disregarded,
minutes.
But once it's
or
complete,
no air
there's a near
resistance, what happens?
perfect
Falls
vacuum
objects
inside.
will at the same constant
60
acceleration.
manual, 10% open. Station 1, go for drop. PCB 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
Look at that.
They came down exactly the same. Wow. Look. That's right there. Look at how they hit right there.
Exactly.
You're back on the side.
Exactly the same.
Feathers don't move, nothing. Look at
Look
that.
at that's
Both
just
pull at the same constant acceleration when air resistance, no air resistance.
Isaac Newton would say that the ball and the feather fall because there's a force pulling them down. Gravity.
Same constant acceleration.
But Einstein imagined the scene very differently. The happiest thought of his life was this. The reason the bowling ball and feather fall together is because they're not falling. They're standing still. There is no force acting on them at all. He
Velocity
reasoned that if you couldn't see the
due to
background,
displacement,
there'd be no way of knowing that the
Change
ball
the
and the
phase.
feathers were being accelerated towards the earth.
so when displacement
So he concluded
change, velocity
they weren't.
will change.
In this lecture, I will teach you the concept of free fall. We know that Earth attracts everything towards itself due to a force of gravity. As a result, the body accelerates towards the Earth. Therefore, the type of motion in which only a force of gravity acts on a body is known as a free fall. Now let's consider that a body falls towards Earth. If I trace its motion path, I come to this conclusion that in time 0 second, the displacement of this body is 0. Hence its velocity is also 0. In time 1 second, its displacement becomes 4.9 meter. Hence its velocity is 9.8 meter per second. In time 2 second, its displacement becomes 19.6 meter. Hence its velocity is also 19.6 meter per second. In time 3 second, its displacement is 44.1 meter and its velocity becomes 29.4 meter per second. Now look at the velocity of a body. We see that the velocity of a body is increasing as it is falling down. Because the body has covered greater displacement between 1 and 2 seconds, then 0 and 1 second. Similarly, the displacement of body is greater between 2 and 3 seconds than 1 and 2 seconds.
So the
Hence,
displacement
every
changes.
second the body covers greater and greater displacement. As a result, velocity of a body increases. We know that when velocity of a body increases or decreases, we say velocity changes. When velocity changes, acceleration produces. Hence, we get that when a body falls towards Earth, its velocity increases. Or we can say that the body accelerates towards Earth. Therefore, falling bodies have acceleration. Now here the question is, can you calculate the acceleration of these falling bodies?
Gravitational
The
force.
answer is yes. We know that the rate change of velocity every second is called acceleration. It means if I find the change in velocity between 0 and 1 seconds, it will give us acceleration. Hence, at time 0 second, our velocity is 0 meter per second, and at time 1 second, our velocity is 9.8 meter per second. Hence, the change in velocity is 9.8 meter per second square. This is the acceleration of this body between 0 and 1 second. Similarly, if I find acceleration of this body between 1 and 2 seconds, it is again 9.8 meter per second square. And if I find it between 2 and 3 seconds, it is again 9.8 meter per second square. Thus, I say that the rate change of our velocity in every second is 9.8 meter per second. Or I say that our velocity is constantly increasing by amount of 9.8 meter per second. Hence, we get constant acceleration 9.8 meter per second square. In physics, this constant acceleration of free fall is known as the acceleration due to gravity. It is denoted by small g. Whenever you see g anywhere in physics, remember that it is acceleration due to gravity, and its value is 9.8 meter per second square. In both cases, if a body falls down towards Earth or if it goes in upward direction. At last, let me ask you some tricky questions. If I throw a body in upward direction, what will be its acceleration at the peak point? I know that if I throw a body with initial velocity of 29.4 meter per second in upward direction, after 3 seconds, its velocity will be 0 meter per second. Thus, at the peak point, the velocity of a body is 0 meter per second. But still, its acceleration is 9.8 meter per second square. The reason is that when I throw a body in upward direction, in this case, its velocity decreases. Now, how much velocity between the last 2 and 3 seconds decreases? I know its velocity decreases from 29.4 meter per second to 19.6 meter per second, then from 19.6 meter per second to 9.8 meter per second, then from 9.8 meter per second to 0 meter per second. Yes, in the last second, our velocity changes from 9.8 meter per second to 0 meter per second. Hence, my acceleration at peak point is 9.8 meter per second square. Lastly, what is the direction of acceleration due to gravity? The answer is when a body falls in downward direction or it goes in upward direction. In both the cases, the change in velocity is downward. Hence, the direction of acceleration due to gravity should always be in downward direction. I hope you have understood the concept.
So free fall is accelerating due to gravity. Free fall acceleration is a constant. Magnitude of free fall is 9.8, which is denoted by G. So G equal 9.8. This is a magnitude or number of free fall. Direction of free fall is directed downward, negative direction. Free fall is denoted with a simple J. Sometimes maybe A for acceleration due to gravity. So either A or G. A equal 9.8, the magnitude of acceleration equal 9.8, whatever G or A. In a vacuum, in absence of air resistance, vacuum means absence of air resistance. There is no air. All objects fall at the same rate. Acceleration is constant during upward and downward motion. So acceleration is constant, whatever upward or downward. Whatever upward like this or downward. A ball threw up into the air with an initial upward velocity. So it threw upward with initial velocity 10.5 meters per second. The photo on the left shows the ball moving up from its release toward the top of its path, and the photo on the right shows that the ball falling back down. Because the object changed direction, so the object will change direction, it may seem that the velocity and acceleration are both changing. Actually, objects thrown into the air have a downward acceleration as soon as they are released. So, objects being thrown into the air have downward acceleration. So, acceleration is constant during upward and downward. That's it. Thanks for watching.